Although ellipses and hyperbolas have completely different shapes, their definitions and equations are similar. Instead of using the sum of distances from two fixed foci, as in the case of an ellipse, we use the difference to define a hyperbola. A hyperbola is a set of all points in the plane, the difference of whose distances from two fixed points called the foci of the hyperbola is constant. So first off, we're going to look at a hyperbola with a center at the origin. So there are two. We'll work with the one on the left, then the right. So here on the left we have the equation x squared over a squared minus y squared over b squared equals 1, where a and b are both positive numbers. The vertices can be found at the point plus minus a comma 0. So this point here and this point here. The transverse axis is horizontal with a length of 2 times a. The asymptotes can be found by using this form here, y equals plus minus b over a x. All you got to do to find the equation of the asymptote is just find a and b, which you'll find a under x and b under y. Plug it in, and you'll have your equation of the asymptote. And it runs like an x here. These two lines will never have the graph of the hyperbola cross it, so it's going to kind of just straddle it, run around it, but never actually cross it. Now, to find the foci, you need to know c, because the point for the foci is plus minus c, kind of inside of the hyperbola. Like if you were to imagine these two curves here as parabola, the foci are going to be on the inside. The only way to find c is you have to use this formula here, c squared equals a squared plus b squared. Make sure it's not minus, it's plus. And using this, you'll be able to find c for the foci. Now for the other equation, it's y squared over a squared minus x squared over b squared equals 1, and a and b are both positive numbers. Now you can tell the difference here is that we had the y second with a negative in front of it, and this time the x is second with a negative in front of it. This does matter where or how you write this, because the fact that x comes second, this graph is going to be going up and down like this, versus where y was second, because where the negative is attached to, it's running left to right. The vertices can be found at the point 0, comma, plus minus a. So again, where the hyperbola touches here and here. The transverse axis has a length that's vertical, and you can find that by just doing 2 times a. The asymptote here is just a little bit different. This time it's plus minus a over bx. So again, find your a and b, but make sure that a goes on top and b goes in the bottom. Again, a is what's underneath the y, and b is what's underneath the x for this equation. The foci are at the points 0, comma, plus minus c. So again, inside of the hyperbola, if you looked at these as parabola. And again, you can find c by the equation c squared equals a squared plus b squared, and it has to be plus, don't use minus. So these are the two kinds of hyperbola you can deal with. The one that's horizontal, the left one, and the one that's vertical, the right one. Make sure you pay attention to the equation and where the minus sign is attached to, and that way you can tell whether it's a vertical or a horizontal. But just like with other conic sections, they can be shifted, and hyperbolas are no different. A shifted hyperbola, in this form here, has the equation x minus h all squared over a squared minus y minus k all squared over b squared equals 1. To find each part of the hyperbola, the center just comes from h and k right here. The vertices can be found by just finding what they were normally centered at the origin. And once you do, you can just add h and k to the x and y value respectively. Same thing with the foci. Find out where it normally would be when it's centered at the origin, and then just add h and k to the x and y value to find out where it's been shifted to. For the asymptotes, just a little bit different. find out what it normally would be centered at the origin, get your b over a, but then you're going to rewrite it in the point slope formula as seen here, and then plug in your h and k respectively to get your two equations for the asymptotes. Same thing with the hyperbola in this form. The equation is y minus k all squared over a squared minus x minus h all squared over b squared equals 1. Again, find your h and k. Again, h is going to be attached to x, k is going to be attached to y, so be careful with the order. And that will give you the center. Once you have the center, then the rest is easy. To find the vertices, just find out where it normally would be, centered at 0. And then just add your h and k to x and y respectively so you can get where it's been shifted to. And you'll do the same thing for the foci. Find out where it is normally, centered at 0, and then add your h and k to get where it's been shifted to. The asymptotes, you will do the same thing as we did on the previous one. Just remember that the hyperbola in this form is going to be a over b, not b over a. But once you have it, just plug it into your point slope formula, then put in your h and k value you get from your equation, and then work it out to get your two equations for the asymptotes.